All right. Hello, everyone. Welcome back for another deep dive.
It's great to be here.
Yeah, it is. We're going to be talking about something today that's been in the news a lot lately.
Yeah.
We've been seeing it all over sources like the Times of India and the India Express. And it's this asteroid, they were calling it 2024 YR4.
Right. And it's interesting for the UPSC folks, this is something that could really come up because it touches on a lot of different areas, space science, disaster management, even international relations.
Yeah, that's true. And, I was reading actually in the Times of India that it's got a small but like not impossible chance of actually hitting Earth in 2032.
Yeah. And, whenever you see something like that, a percentage chance of something like an asteroid hitting the Earth, it can be a little bit alarming.
Yeah, definitely. So today we're really going to deep dive into all the facts, about this asteroid 2024 YR4, like how much of a threat is it really, and what are people doing about it, all that good stuff.
Yeah, absolutely. I think a good place to start would be just like, what is this thing?
Right.
Like, what are we even talking about here? And they're saying it's medium sized, right? Which I don't know about you, but that doesn't tell me a whole lot.
Yeah, no, not really medium size. Space is big. What does that even mean?
Exactly. Well, they're estimating that it's somewhere between 40 and 100 meters wide.
Okay.
So think of like a football field.
Oh, okay. So like a football field flying through space.
Yeah, basically. Hurtling through space at incredible speed.
That's a scary thought.
It is. And it was actually just discovered recently, like December of 2023.
Oh, wow. So it's pretty new on the radar.
Yeah, relatively speaking, yeah.
And so then they're saying that 1.2% chance of hitting Earth, was that based off of just that initial like discovery and those initial calculations?
Yeah, so scientists are working like crazy right now to kind of get a better handle on its trajectory,
Yeah.
but they're in a bit of a time crunch. Yeah, because it's actually going to be fading from view in mid-April,
Oh, wow.
and it's because as it moves further away from Earth, it gets dimmer
Oh.
and it's harder to track.
So we only have like a small window to like really study it.
Exactly. And that's why it's such a big deal right now because they need to gather as much data as they can while they still can.
And so once it fades from view, are they like just kind of like estimating where it's going to go based off of like what they were able to gather? Or...
Yeah, they use the data they have to make projections, but the further out you go, the more uncertainty there is, you
Right.
know? So every little bit of information they can get now helps them refine those predictions and kind of narrow down that range of possibilities.
And that's part of the reason why they're having such a hard time pinning down like the exact size, right?
Right.
Because I know you mentioned that, 40 to 100 meters wide, that's still a pretty big range.
It is. And part of the challenge is that, like, brightness can be deceiving,
Yeah.
Like a large dark asteroid might look similar to a smaller, brighter one through a telescope.
Ah, okay.
So until they can get like more precise measurements, it's tough to say for sure exactly how big this thing is.
Okay. And why does the size matter so much? Like aside from obviously, the bigger is the bigger the boom, but like is there anything else?
Yeah, there are actually a couple of key reasons why knowing the size is so important. First of all, like you said, the size directly relates to the impact energy, right? So the bigger the asteroid, the more damage it could cause.
Right, makes sense.
But also, knowing the size helps us figure out, like, what kind of mitigation strategies would even work? Like, if we needed to, like, try to deflect this thing, the approach you'd take for a 40-meter asteroid is going to be different than what you'd do for a 100-meter one.
Right. Okay.
Yeah.
So it's not just how much damage it could cause, it's also like, what can we even do about it, really?
Exactly. So it's a crucial piece of the puzzle.
So, okay, so we've got this, football field-sized asteroid hurtling towards Earth, small chance of hitting us. But still, you see that 1.2%, and it's like, uh-oh, should we be worried?
Right. I think it's natural to have some concern, but it's important to keep things in perspective.
Okay.
1.2% chance of hitting also means that there's a 98.8% chance that it's going to miss us completely.
Okay.
And actually, NASA has come out and said there's a 99% chance that it'll miss.
Oh, wow. Okay, so not exactly a doomsday scenario.
No, definitely not. But it's definitely something to keep an eye on.
Right. Okay.
And to kind of put that that percentage into context, remember a few years back, the Apophis asteroid?
Oh, yeah.
That was, when it was first discovered, it was given a much higher risk rating.
Really?
Yeah, it was initially a 4 on what's called the Torino Scale.
And what is the Torino Scale?
It's basically, it's a scale from 0 to 10 that helps us, like, assess the risk of an asteroid impact.
Oh,
So 0 is like no risk at all, and 10 is like we're all doomed.
gotcha.
So a 4 is, that's pretty significant, you know? It means that it warrants careful monitoring.
Okay.
But with Apophis, as they got more data and were able to refine their calculations, they ended up downgrading it.
Oh, okay.
So it's a good example of how, you know, these initial predictions, they can change as we get more information.
Right. Yeah. So even though we see this 1.2% chance,
Mm-hmm.
with YR4,
Mm-hmm.
it's good to remember that that number could change as we learn more.
Exactly. It's a fluid situation.
Okay, so let's say hypothetically, though, that it does hit.
Okay.
Are we talking like dinosaur extinction level event? Or
No, not even close.
Okay.
But it wouldn't be pretty.
Go.
So scientists estimate that an asteroid of this size could release somewhere between 8 and 10 megatons of energy on impact.
Okay, and just to put that in perspective, like how much is a megaton?
So to give you an idea, the atomic bomb that devastated Hiroshima was about 15 kilotons.
Oh, wow, okay.
And a megaton is 1,000 kilotons. So
Hundreds of times more powerful.
yeah, we're talking orders of magnitude more powerful.
Wow. Okay, and I remember reading about the Chelyabinsk meteor. That exploded over Russia back in 2013, I think it was.
Yeah.
That was smaller than 2024 YR4.
Right.
But it still did a lot of damage.
It did, yeah. It was a stark reminder that even relatively small asteroids can have a significant impact, literally.
Yeah, and the Indian Express had some pictures of like the damage that it caused.
Yeah, it caused widespread damage, like shattered windows across 6 cities, injured over 1,000 people.
Wow, okay.
Most of the injuries were actually from flying glass.
Oh, okay. So even though it might not be like, global catastrophe, it could still be pretty regionally devastating.
Absolutely. And the exact effects would depend on a lot of factors, like where it hits, the angle of impact, things like that.
Right. Yeah. So there's still a lot of unknowns.
Definitely. But the good news is we're not just sitting ducks, you know? Like, scientists have been working on ways to protect our planet from these cosmic threats, and a key player in that is NASA's DART mission.
Oh, yeah, the DART mission. I remember hearing about it. What exactly was that all about?
So DART stands for Double Asteroid Redirection Test, and basically what they did was they crashed a spacecraft into an asteroid
Oh, wow.
to try to nudge it off course.
And it worked.
It did. It was a huge success.
Wow.
Like-
So like we actually have a way of like deflecting an asteroid if we need to.
Potentially, yes.
Oh, that's incredible.
Yeah, and it was a really big deal because it showed that we're not powerless against these threats from space, you know?
Right. Yeah. It's not just like, oh, well, whatever happens. Like we can actually try to do something about it.
Exactly. And
Yeah.
and while DART was targeting a small asteroid and it wasn't a threat to Earth, it paved the way for future missions that could be designed to protect our planet.
So this was kind of like a test run.
Yeah, a proof of concept,
Right.
and it worked beautifully.
Okay, so we've learned a lot about this 2024 YR4, medium-sized, small chance of hitting Earth. We're monitoring it, and we even have some tools like this DART technology to potentially deflect it if we need to. But this brings us to a bigger question, and I think especially for, our listeners who are preparing for the UPSC, aspiring diplomats and policymakers, what role should international cooperation play in all of this?
That's a great question, and one that I think we need to really dive into, but maybe we should save that for the next part of our deep dive.
Yeah, I think that's a good idea. We've covered a lot of ground already.
We have.
So we'll pick up that conversation on the next part.
Sounds good. Looking forward to it.
Yeah, me too.
When you think about it, these asteroid threats, they're not really a one-country problem, are they? It's a global issue.
Yeah, that's true. I mean, an asteroid could hit anywhere.
Exactly. So dealing with them effectively, it really requires a coordinated international effort.
Right, because, no single country have all the resources, all the technology, all the expertise.
Right. You need everybody on board.
So what would that kind of international cooperation like actually look like?
Well, think about it, like step by step.
Okay.
First, you got to detect these things. You got to track them.
Okay.
That requires a network of telescopes and observatories all over the world, sharing data, coordinating their observations.
Right, because one country might spot something that's like initially heading towards another part of the globe, right?
Exactly. And the earlier you can detect it, the better. So global collaboration, super important for that initial stage.
Okay. And then once you've detected something, what's next?
Well, then you got to analyze the data.
Okay.
You got to make predictions about its trajectory. Is it going to hit us? Where, when, all that stuff.
Right.
And this involves, scientists from different countries working together, sharing their expertise, running complex simulations.
So it's not even just like sharing the information. It's like actually collaborating on like how to interpret that information.
Exactly. You need the best minds from all over the world coming together to assess the risk, figure out what to do.
And then like I guess the trickiest part is if you actually have to do something, if you need to, like deflect it, right?
Right, and that's where it gets really tricky because deflecting an asteroid, I mean, that would likely involve multiple space agencies, from different countries,
Yeah.
each one contributing their own strengths, their own technologies.
Wow, that would be a huge undertaking.
It would be.
Yeah.
Just the logistics alone, the coordination.
Yeah. And I imagine there'd be a lot of like diplomatic negotiations too.
Oh, absolutely. I mean, who gets to make the decisions? How do you share the resources? Who takes the lead? I mean, it gets complicated fast.
Yeah. Yeah, it does.
And it's not just about, sharing the burden. It's also about responsibility, like making sure that any actions that we take to deflect an asteroid, that they're done responsibly and with global consensus.
Right. Because you don't want one country just deciding to like nuke an asteroid without consulting anybody.
Exactly. I mean, think about the potential for unintended consequences or even international conflict.
Yeah.
So we need clear protocols, we need mechanisms for international decision making. Any actions that are taken, they got to be based on the best available science and with the full participation of all the stakeholders.
So it's almost like a cosmic version of like the UN Security Council or something, but for asteroids.
Yeah, exactly. You need a global body that can make these tough decisions.
So in a way, this asteroid threat, it could actually be a good thing.
Oh, you mean?
Well, like it could force us to cooperate more, to work together, like to solve this common challenge.
I see what you're saying. Like it could bring humanity closer together.
Yeah. Like we're all facing this common enemy, except the enemy is a giant space rock.
Yeah, I like that. It's an opportunity to build stronger bonds, to build trust, develop new frameworks for collective action.
And that's something that's definitely relevant for UPSC aspirants, right?
Absolutely. I mean, the UPSC exam, it's not just about knowing facts. It's about understanding these kinds of connections, thinking about how seemingly different issues, they're actually all linked together.
Yeah.
And this asteroid threat, it's like a perfect example of that.
Yeah. Because it's science, it's
Mhm.
technology, it's politics, it's international relations, even economics, right?
Yeah.
Like who's going to pay for all this?
Exactly. It touches on so many different areas, and the UPSC exam, it's all about making those connections.
So, okay, we've talked about like the need for international cooperation, but are there any like actual agreements or organizations that are already addressing this issue?
Yeah, actually there are. Yeah, there are. So there's this organization called the International Asteroid Warning Network, or IAWN for short.
Catchy.
Yeah, and it's basically a collaboration of space agencies and institutions from all around the world.
Oh,
And they're all dedicated to detecting, tracking, and characterizing these potentially hazardous asteroids.
so it's kind of like a global neighborhood watch, but for asteroids.
Yeah, exactly. Everyone's keeping their eyes on the skies and sharing information.
Okay, that's good. So we've got like the detection and the tracking covered.
Right,
But what about the actual doing something part?
right.
Like if we find an asteroid that's heading our way, are there any like international agreements on how to handle that, like a deflection mission?
So that's where things get a little bit trickier. There aren't any binding international treaties specifically for asteroid deflection, at least not yet.
Oh, okay.
But there are discussions underway. There's a UN committee. It's called the Committee on the Peaceful Uses of Outer Space, or COPUS.
Scup.
Yeah, and they deal with all sorts of space-related issues, and planetary defense is becoming, a bigger and bigger part of their agenda.
Okay, so it's on the radar, but we don't have like a set plan yet.
Right. It's a work in progress, which I think makes it even more interesting for UPSC aspirants, especially those who are interested in international relations and global governance.
Yeah, absolutely. It's like a real-time case study of how the world is trying to grapple with this new and complex challenge.
Yeah. I mean, just imagine you get a UPSC mains question asking you to analyze the challenges and opportunities of international cooperation in planetary defense.
Ooh, that's a good one.
Right. You could talk about these existing initiatives like IAWN and COPE-US.
Okay.
You could highlight the need for more robust legal frameworks. You could even propose your own solutions.
Yeah. That's a great point. It's not just about, memorizing facts. It's about really thinking critically about these issues and coming up with your own ideas.
Hmm. Exactly. And I think, what's really fascinating about this whole asteroid thing is that it could actually push us towards stronger global governance, greater cooperation.
Kind of like a threat that unites us.
Exactly.
Yeah.
Just like, the threat of nuclear war during the Cold War led to arms control treaties, international organizations.
Right.
This shared challenge of asteroid impacts, it could drive us to find new ways to work together to ensure the safety of our planet.
It's a hopeful thought in a way, right?
Yeah.
Like out of this potential danger could come something really positive.
I think so. And it's something that, to keep in mind as you're studying for the UPSC. It's not just about asteroids. It's about this bigger idea of global cooperation, global governance, and India's role in all of that.
Yeah, that's a really important point.
Mm.
Okay, well, we've covered a lot of ground today,
Mm.
from the specifics of 2024 YR4 to the broader implications of these asteroid threats and the need for international cooperation. But before we wrap up, I just want to remind everyone that all this information, it came from some excellent reporting in the Times of India and the Indian Express.
Definitely.
So we encourage you to check out those articles for further reading.
Yeah. Do your own deep dive.
Exactly. And if you have any questions or you want to explore any specific aspects further, please leave a comment below. We love hearing from you.
Yes. And don't forget to like and subscribe to our channel for more deep dives on current events relevant to your UPSC journey.
All right. Until next time, keep those brains buzzing and best of luck with your preparations.
See ya!